Good morning, Math 2 students. This is Miss Brown. Today we're going to start similar triangles. Now, the last couple of days we've been working on congruent triangles. Today we're talking about similar triangles. Before we can get into similar triangles, though, we have to remember how to solve a proportion. Today's lesson is just about proportions. So I have attached a couple of worksheets for you on your Google Classroom. This first one here is just a page of notes, and then you have a couple of pages of practice problems to try. So I just want to remind you what a proportion is and how we solve proportions. This is very familiar to you, it should be. A proportion is just when you have two fractions or two ratios that are set equal to each other. So here I have one fraction and it is set equal to another fraction. That is what a proportion is, two fractions that are set equal to each other. The way that we solve is we cross multiply. Now, it's important to remember that this is an equation, so you make sure that you always have two sides of your equation. When I distribute here, I'm going to multiply this diagonal together. That will be one side of your equation, and then you will multiply the other diagonal. That will be the other side of the equation. Now, one thing I want to point out here is that this fraction has two terms in that numerator. That is a binomial, and so does this fraction. So I rewrote this with parentheses around those binomials. I like to add this step in because it's really important that you don't forget to distribute when you start to cross multiply. So here we go. When I cross multiply here, that 9 is going to get distributed to the x plus 2. And then on the other side, the 5 is going to get distributed to the 2x minus 1. Make sure you keep a balanced equation. So when I distribute here, I end up with 9x plus 18. On this side, we end up with 10x minus a 5. Now from here, this looks like a basic Math 1 equation now where we can solve. The steps that I skipped here is I just subtracted the 9x's over here to this side, so I'm left with 1x. And to get rid of subtracting 5, I added the 5 to that side, and this is how I got my answer. Okay, let's do another example. Here's the first problem on your Solving Proportions worksheet. So we have this fraction set equal to another fraction. That is a proportion. Now I'm going to do my work over here on a separate sheet of paper. Okay, because this first fraction has a binomial in its numerator, I'm going to put parentheses around it so that I don't forget to distribute. So when I cross multiply, the 7 will get distributed to the a plus 29, and the 2 will get multiplied by the 2. So I have my 7 times my a plus 29. That's one side of the equation, and then 2 times 2 is 4 that's on the other side. So I will distribute. 7 times a is 7a. 7 times 29 is 203. And now I have a basic Math 1 equation that I'm going to solve for. Now, hopefully you remember in class, I used to put a circle around that equation and drop that line there so that I can clearly see two sides of this. I want to make sure that whatever I do to one side, I do the same thing to the other side. So since I'm solving for the variable a, the first thing I'm going to do is get rid of adding 203. So I'm going to subtract 203 from both sides. So I am left with 7a's is equal to a negative 199. Now to get rid of multiplying by 7, I'm just going to divide by 7. Now guys, on this worksheet, some of these answers have really gross fractions. And when you get something that will not reduce, you can just leave it in fraction form. It is perfectly okay to have answers that are left as fractions. So I want you to practice some proportions where you just cross multiply today, and I have provided the answer key for you as well. The other thing that I want us to talk about real quick is some properties of proportions. One of your worksheets has a couple of true-false questions where you will have to use these 4 properties to answer those questions. So in this example, we have this proportion here. The first property is the cross multiplying that we just went over. If A over B is equal to C over D, then of course we can cross multiply, and A times D is equal to B times C. That's the first property of proportions that we just went over. But there are 3 other properties that go with proportions that I want you to look at real quick. The key to doing these properties is to be consistent. So when I look at my original proportion, if A over B equals C over D, the second property says that you can take the reciprocal of both fractions and it is still a true proportion. Meaning if I flip this around, I can put B over A right here, and I can put D over C, and that is a same true proportion as the original. The key here again is being consistent. If you flip the first fraction and change it from A over B to B over A, then you must flip that second fraction from C over D to D over C. That is a property that works every single time. If you've got a proportion, you can take the reciprocals and it is still a true proportion. Property number 3 is a little bit different because we're actually jumping from one ratio to the other. Instead of A over B equals C over D, you can work with the numerators. A over C, which is the first fraction, is equal to B over D, which is the second one. And again, the key is being consistent. If I say the left over the right, do left over the right. It does not work if you say A over C and D over B. That will not work. It has to be left over right, left over right. That is another way you can set up your proportion. And then finally, the fourth property involves some sums. So again, being consistent, if I look at A plus B over B, basically I said top plus bottom over bottom. If I'm being consistent, I can say C plus D over D, top plus bottom over bottom. So these are 3 special ways that you can rewrite your proportion and still have something that you can solve. Okay? This last note here is going to take us into what we're going to be doing tomorrow on similar triangles. This little symbol here just means similar. So if triangle ABC is similar to triangle XYZ, that means that they're like dilations. One is just a smaller version or a larger version of the other. If they are similar, that means that all of your angles are still congruent to one another, but the corresponding sides, instead of being congruent, they are proportional. This is the reason we're studying proportions and how to cross multiply, because proportions are very important for what we're going to start tomorrow when we look at similar triangles. So today I want you to do your very best to try to complete the worksheet on proportions. And you can email me if you have any questions, and good luck.